Hello boys, I'm not sure if we're live now, but this camera is definitely not okay. Is it? There you go. It just seems to be a little bit wrong, if I'm honest. There you go. You can see me fully now, and unfortunately you'll be able to see the spot on my face as well. Just on the stream day, I always get a nice little spot. And I'm gonna wait to do some audio checks. I can't really see the stream at the moment. But let's see. Still says connecting the software. Audio checks? Testing, 1, 2, 3. Software. Testing. Audio checks? Testing. There you go. We're live and everything is working fine. And welcome to another stream. I'm glad to have you guys here. I know that there's not anyone watching at the moment, but surely there will be some people later on. And also for the people in the future, welcome to another C++ stream today. We're again going to be working on the ECS. I'm actually quite into this project at the moment. So for those who are kind of new to the channel and just kind of clicked on the video, we started making this C++ entity component system, which kind of aims to support any sort of like structure as a component, and it's kind of very easy to create entities, right? So we are still on the beginning of the development phase of this. And to be honest, the idea for this whole thing is so that I can have like a bit of a longer project here on the channel where we create a very simple game using our own ECS, right? So that's the idea for this whole thing. So for those who kind of haven't really worked with ECSs before, long story short, ECS is basically like an alternative for inheritance. So you have aggregation over or composition over inheritance. I think that's the key here. Hello, Robin. Dude, I was actually thinking about you today. You know, I was like, shit, I've not heard from Robin in like ages. So I'm gonna message him later on. I was actually gonna message you later on tonight to see if everything is going okay. But I hope you're doing okay, dude. Yeah, long time no see. I've got a code Coca-Cola on here. Hopefully you guys heard that. Yeah, going back to this, so you have a composition over inheritance with ECSs. So every object or every entity can have a kind of like a list of components, right? So you can have a rendering component, you can have like a physics component or something like that. And you get the idea. So you don't have to create like a bunch of classes and a bunch of inheritance mechanisms to have all of that functionality with associated with one object. I'm finally done with school. Nice, man. Nice. It's very good to hear. It was a rough 2 weeks. Yeah, well, congratulations, man. If there's 2 people watching, right? So can I get a heart emoji here from the other person as well? Because yeah, well done, Robin. You've completed it, dude. You've basically completed life now. So from here onwards is basically like I'm not gonna lie. You're probably not gonna have any stress in the same way as you had with uni. Because I still think that my uni years were some of the most stressful years of my life. And when I finished, I remember that feeling of like not having to do any of that stuff anymore. And then just thinking to myself, like, I've completed it. This is what my parents wanted. This is what I wanted to do. And it's done now. And I don't ever have to do anything like this again. Unless you want to go into like a PhD or something, then yeah, you probably go for another 4 years of that if you want. But yeah, well done, man. Well done, and I'm looking forward to hearing more about your career now. Anyway, I've spoken too much. I'm gonna just drink some Coca-Cola. We're still not sponsored. Please, Coca-Cola, sponsor us. I will happily take your money. So yeah, I mean, essentially what we have here is like a very basic ECS where the actual ECS in our particular library is just a map, right? So we basically just have a map where we store the component ID for a class. So for example, if I create a structure called a circle component, right? Where I store things like X, Y, and the radius, so the center and the radius. We get an ID for that at compile time, and we add it into this map. And we also create an empty vector where it basically stores a pair of entity IDs and then the component data itself. So the kind of circle class, so the instance of the circle class associated to this entity ID, right? And this is actually very, very efficient because I'm not mistaken, pair is basically it's just like a pure data kind of thing. And you have vector, which is a very, very sort of contiguous, very, very efficient contiguous bit of memory. So if you're looking at all of the entities that have a circle component, you can just iterate over them, and that's going to make a very, very good use of the caches, the CPU caches, which makes any algorithm doing this very, very quickly. So this is the idea here. The idea is to make this map very efficient for us to look up. Because one of the things with ECS is that you can do something like, I want to, oh, why is this so small? I want to basically get from my ECS registry the component, circle and square. And this would return me like all of the entities, or a list or a vector with all the entity data, where I have like ent1, data 1 or something like that. So this is the idea here, right? This is what we kind of want. But yeah, so just to reiterate, we want to make sure that we store the data in a way that we can do multiple lookups. So we can do something like, get all the entities that have a circle and square, and that will return to us something like this, or a tuple that has entity, the circle data and also the square data here, right? And preferably this is going to be stored in a vector to make things very fast and very cacheable. But this thing is actually very, very difficult to get, if you think about it, because you're going to have to store, you don't want to have to copy things around. You don't want to have the same data stored in different maps, like more than once, essentially. Because at the moment, what we do is we make it very easy for us to get one component, and that will have like all your entities in a vector here, right? But we don't really make it easy by doing a simple map to do multiple components, right? And I've got an idea for that, and we're gonna kind of draw some things out here. I'm hyped to catch more streams now. Thank you, Robin. So the idea here is that today we're gonna try or begin to transform this basically this registry map into something a little bit better. We're still going to use a map, right? But what I'm suggesting is that we, instead of having a component ID here, we have something like I'm just gonna reuse this thing here. Well, actually, let's keep it here. So this is our goal, right? This is our goal. We want to make storage of entities kind of easy in this way. So we have something like this, right? So this will be something like a very fast lookup into a map, and we don't have to do any data transformations. We're just going to have this data for us here, right? So what am I suggesting? What I'm actually suggesting is that instead of using a map like we have here, where we've got some, oh my god, I can't copy Excalibur. What is this? Thank you. So we're gonna basically, instead of having a map here, we're gonna have a bit mask or a component bit mask, and then a vector of entity to a tuple, I guess, or actually it's gonna be a tuple, right? Of components in the order here, right? So I'm gonna explain what this means in a second. No, I'm gonna explain it right now, actually. I'm hyped. Hello, Slim. I'll be on the side because I'm helping family. Dude, thank you very much for helping out. And yeah, just like the video, dude, and then you can go and help your fam out. But it's good to see you, man, and I hope you're having a good day. By the way, if you haven't done it yet, please like the video. Please like the video. It does help me out quite a lot. So what is this bit mask? This bit mask is essentially just going to be like a stud uint64t, right? So basically just an ID, where the ID tells us exactly which components we have in the tuple here, right? So that's what we want to do. Now let me think how we're going to do this, because this is actually very tricky. This is actually very tricky. Yeah, so what I'm doing is like, say we have, for the sake of this this example, we have these components, right? So we have the circle and the square component here. And we only have 2 here. So the bit mask is going to be something like, you know, we can either have 0, 0, or we can have, you know, there's obviously more than those 2. 0, 1 is going to be a 64-bit integer, or we have 1, 1 there. So what does this tell us? So this one here, let me move this just so it matches this shit here, to be honest. Oh, actually, let me just edit this. So 0, 0 means that these components have, the entities in this list have no components, right? Right? And then the entities on this other list here has whatever is the first index on the component list, which is just a circle component, right? And with circle, right? We obviously forgot another one. If you guys do kind of bit tables, we also forgot this one. This one means entities with the square and component, and then this one means it will store all the entities with a circle and square, right? So what am I actually kind of suggesting here? The suggestion is that we try to implement something or a map that the key will be simply an unsigned integer with 64 bits, which kind of by this logic here means that we only support 64 different components, but I don't really see anyone having a lot more than 64 components. Like, who has 64 different structs that they use as components? I don't know. We can obviously make the size of the integer a lot bigger as well by expanding it later on, maybe with a tuple or something like that as the key. But you know, this is fairly scalable for what we want now. And each unique integer is gonna basically signify what components the entities stored in that vector or in the value will contain, right? And that's it. Now, the difficult bit is basically like whenever we create a new registry at the moment with our C++ thing, we say something like, no, the registry auto const registry. Ooh. That is equals to whatever, is it ECS? I can't remember what it's called. I think it's may ECS or something like that. This is the call syntax, may ECS. Actually, Robin named it, and Robin is here right now, so thank you very much, Robin. ECS. And then we have registry. And then we put the allowed components in here, right? So we do have circle, we have like square, and whatever else in here, right? So in a way, we do know at compile time which positions these circle, square, and ... will be, because you can get that information from variadic templates in C++. So it makes this kind of logic of translating the integer, right, something like this, to which component it means very, very easy. In C++, you can do that very, very easy, right? And we're also working a lot with variants. So in C++, all the component data is stored as a variant, right? So we essentially have this part here of the map that I'm suggesting is a variant, right? So it'll be like a variant of a C's. C's are the components here, right? So these C's will just be, you know, whatever's inside the registry when we create it here. So this is going to be difficult. I'm not going to lie. This is something that is very, very difficult to implement, but we can get started on this anyway, right? So we do have an initial plan. This is, I don't know how many streams this will take. I'm happy to go on for like a few hours, but I really doubt we're going to get to finish all of this in one stream. But we are going to get started anyway. And all of this is going to be useful when we actually come to implementing this. Oh, what just happened there? Guys, I'm really confused with the UI here on Excalibur. Things are just like happening. Oh, this is cool. I can select all of them and then just like resize all of them. So basically, this is our goal for today, right? We're going to keep it here. And by the way, if you are a programmer, if you're new to things and you don't use Excalibur or any kind of like sketching tool, I highly recommend that you start, because it's really, really easy to kind of like start with a very complex problem, break it all down, and then just like sketch it out, keep it there so you can like refer to it back, and then figure out like which small bits you want to implement first I find it extremely useful, and this is something that keeps popping up at work all the time. So whenever I get moved to a very, very like complex task at work, which coincidentally I've started working on something that's actually very, very hard recently. I find it extremely easy to break down the problems and then just like do it bit by bit. Like start with the easy stuff first, and then just keep like implementing, keep making it more complex until you've reached your goal. And this is why I recommend Excalidraw. It's a free tool, anyone can use it, and that's why I use it here. But anyway, let's start this. So that particular map that I was talking about, you can see it being implemented right here. So where is it? So entities there. For every component that we register, for every like class or structure that we register in the registry, we have this map of component IDs as well, which has like a component name and the component ID itself. This is going to come in useful later on. But what we're going to do is like, we basically want to create the entity mask to entity data map here, right? So I think we're still using Uncurl, yeah. Uncurl, ordered, dense map. This seems to have, Uncurl actually gave us like the best performance for the book, I think, compared to an ordered map. So we're still going to use that in today's stream. If you're interested in knowing how much faster Uncurl's unordered dense map is, check out the last video. I think the link will be on the description if I'm not mistaken, but yeah. So what I'm suggesting is that we simply change this to kind of uint 64t, right? Something like that. And then the actual data, what are we going to store it as? So it can't be a pair anymore because we may have like kind of, I'm trying to think of it. We may have like a lot of entity data in here. So like each entity is probably going to have more than one component, right? And the number of components that we have essentially is the size of in other words, is how many ones we have set in the uint64t, right? That is the size of things that we have. And this is actually kind of difficult to kind of store in a performant way, because I could do something like this, right? I could do a stud pair of entity ID to a stud vector of component of C's, right? I don't know how many angle brackets, how many freaking angle brackets do we have to close here? So 1, 2 for the vector, 3 for the pair, 4 for the vector, 5 for the map. Jesus Christ. So we could do something like this, but then it's no longer performant anymore, because if you think about it, we have a vector that storing pairs of entity IDs and another vector of components. So you can't just kind of iterate over things because you have double indirection. I mean, it's still better than nothing, I think. But I'm wondering if we can do it as a tuple instead. Dropping it to say hi before taking kids to bed. There you go. Glad my ECS is growing. Yeah, dude, I'm glad it is as well. Yeah, hello Ahmed. Well, it's good to see you here, man. I hope you're doing good, man. And guess what? I've got a Coca-Cola Zero again. I hope you've got yours too, man. That was deliciously cold. Deliciously cold. Please like the video, man. That'll help me out quite a lot. So I don't know. The reason why I can't have a tuple here is because I don't really know the size of the tuple yet. Unless, right, this is the important thing. Unless I make it a tuple of fixed size. And the fixed size is going to be maximum 64 things in it, right? Oh my god. This is difficult. But then those things will have to be optional values, because, you know, an entity may or may not have a certain component. So yeah, this is getting difficult. This is getting very difficult. For now though, let's do it the thanks, you are the chat. Bye. No worries, man. Thank you very much for joining. Also, let me just remove those heart emojis, because every time I look at the chat, I always miss 1 or 2 letters, just 1 or 2 words, just because of this freaking heart emoji. Yeah, so right now I'm just tempted to do the vector. But then we have double indirection, which makes it no longer kind of useful for us. Because ideally we want something like this. We want to have the components in place, right? That's what we want to have. We could have a double lookup, right? We could have entities with, like we could have a map with a different type for each sized component. But then that's making things very, very difficult. Yeah. But anyway, so let's store this with a vector for now. This is not going to be performant, but yeah. So we have a vector of components, and we're hoping that the vector, like each entity ID, how many components will it have inside the vector? That depends on how many ones are set in this, right? That's essentially what we have. Let's just put a note here. So for example, this to entidy, component 1, component 2. Actually, let me set more than one here, just for the example. That's what we're kind of hoping to store here, right? So a pair of entity ID and the vector of components. And this means the entity ID has components in indexes 0 and 1 of the C's, and the data is in vector. Right, this is what we have. As easy as that. So we have like a double indirection. It's no longer just a matter of iterating over things here. But yeah, it is what it is. Now, what becomes really interesting, like what does this actually mean for our ECS? So when we have entities with just one component, so something like that, right? So this will certainly mean that we have something like this with the entity ID, and we're just going to have one value here, right? But what happens if I add, you know, what happens when I add, say, component 2 or C2 to entidy? Now, entidy is going to have to be like moved from wherever this key is in the map, or wherever this vector is in the map, to a different vector. So I will have something like, something like this, right? So like 001 is going to be actually containing that entidy, which has, you know, C1 and component 2 there. And what happens to the old one? So the old one is just going to have nothing in it because it will be moved from this one to this one, right? So it's worth thinking about these things, because these things will quite literally make our logic a lot more complex, and it's just what it is. So yeah, I think we've got a plan now, right? So this is ideally the entity stuff that we want to, the stuff that we want to implement. So we want to populate this thing here, and we want to make sure that this cases are met. That's all. So 167 IoT instruction core dumped build main yeah. Average C++ experience there, Slim. So if you ask me, that's just that just builds character, man. I remember, like when I was starting to program, I literally wrote a program that was supposed to print hello world, and it just core dumped for some reason. Yeah, that was very interesting. Actually, it was supposed to add a few numbers, and then it core dumped after saying hello world. But yeah, that's just me doing the wrong thing, or messing with pointers when I'm not meant to. But you can do that in C++. Very easy. It's very easy to shoot yourself in the foot with C++. Right. So let's think of something now. Let's first of all create a function that will translate between a component and a component list, right? And a bit mask. So that's the first thing we have to do. So in other words, let's go back here to xCaliDraw, and that's what I'm saying. Always draw a diagram whenever you guys are like faced with very difficult problems. So what we want to do is like give in something like something like, you know, get circle and square, or in fact, bit mask. Ooh, gosh, bit mask of circle and square. What we want to get is something like this, right? And say we have like a registry here. I can't stop burping because of Coke Zero. So given a registry like this, so we have autoconst registry, which kind of looks like that. When we do a registry.bitmask of this, it should return a bitmask that looks like that, right? That's what we want to do here. So yeah, let's start with this. So first of all, do I have a header? No, oh yeah, I don't have a header file because we're working with modules. I always forget about this. So yeah, let's do this here. So std size t. So bitmask. And we're all gonna return a size t here. But obviously this should be templated because we're gonna be template type. Oh. Is it C's like that? I think it is, right? How do we do? Yeah, type name dot dot dot. Variadic. I always forget, like, that's the thing with working C++. I'm not sure if you guys have this, but this is what I have with working with templates, or variadic templates in C++. I always forget where the damn dot 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 goes. Is it here, or is it after the C's? So when you're defining it, it should go after type name. But when you're actually using the variadic template, or when you're expanding it, it should go there. And I always forget which order it is. Wrong window. Non-caffeine. That's alright, dude. You should get yourself some Coke Zero. I'm gonna repeat, like, I'm gonna say Coke Zero until they sponsor me. Swear to God. I'm drinking a lot of caffeine now, but really I should not be drinking Coke because I need to get some sleep, as I'm traveling to London tomorrow for like 3 days. And I absolutely hate traveling to London. I don't know about you, man, but like, London is in itself a very stressful city to be in. But also because I have to wake up early to get a train, it makes it like 10 times like worse, to be honest. Because I get to London and I'm already tired, then I have to go into my office and then work for like 8 hours. And yeah, there's just too many people around. Come visit me soon, bro. Yeah, dude, yeah, invite me. Invite me to your home and I'll come around. I'll do a live stream on your home, mate. We'll have KFC together or something. Yeah, definitely, yeah. I mean, if you are, I don't think I'm doing anything tomorrow, man. So if you are actually serious about this, just message me on Discord. To get some lunch or something. It's not lunch, but sorry, some tea or some shit. Get some chicken. Funny fact, I used to be a vegetarian until very recently, when I went back to eating meat, just so I can get a nicer body and lose some weight because I was getting too fat. So yeah, boy. So we have bitmask, right? Now the thing is, what I want to do here is the following. So given the C's, I want to make sure. Oh gosh, why is this so difficult? I want to find, like, let's say that C's are equals to this, right? So C1, C2, C3. I want to kind of transform this into an integer where we have 0, binary, and then we have something like, you know, dot dot dot, and we have, because this is little endian, I'm just going to be writing in little endian format. We're going to have something like this. So we have C3 here, and then we have C2, and then we have C1. Like something like that, right? This is what I want to get. So, you know, this can, each C3 thing here can be like either a bit 1 or a 0. That's what we want to do. Now, yeah, this is going to be difficult. This is going to be difficult because I want to make sure We have C's already in the name here, so we can't use that. So we have let's call it subcomponents. Yeah, so for each of the components inside the subcomponents, I want to go back into the C's here for the class and actually ask the registry, like, where in the C's is this position at? So that is that. That's that. I may actually make use of variant, because variant does have an index of thing in here in the standard, right? So if I'm not mistaken, in the C++ standard, in the variant struct, oh, what am I doing? Variant. There is an index of function that maybe we can make use of that kind of does this. I remember seeing this last time, but this is difficult, my man. I'm running out of Coke Zero already. Fuck. Shit, that's war. This is not going to be kid friendly. So variant size, all right. I thought it was this. I swear to God, it was this. Where are the methods for this? Operator, variant size, index of. Come on, there you go. Index. That's one. So this returns the zero-based index of the alternative that is currently held by the variant. No, so this is not going to be useful, right? But we might have a C++ function that kind of does this for us. So C++ index of type during variadic template expansion. This is kind of what I want, right? Indices trick, yay. So let's see. Oh yeah, there's indices in C++. I forgot about this type. So let's see how they do it. So we create something here, return template class size t indices. I don't understand this. Gosh. I hate having to look at complicated C++ examples online. It's just very difficult. Of course, I strongly advise using a smart pointer and a vector instead of raw pointers. Okay. With C++ 17 constexpr, we can get a much more readable, intelligent implementation of index lookup function. I never managed to get my head around the other answers. Here, I like this one. This one sounds like it should be nice. So constexpr size t, get type index in template list. So we have a target, we have a list head and list of tails. And then we have if constexpr. I like that. I really like this solution because I can actually understand it. Now compare this solution to these ones here. I have no idea what these ones are doing. But quick question, what's the best way to handle exceptions? The best way to handle exceptions is you turn them off. That's basically it, my man. You turn them off. I mean, the only way to do with C++ is try and catch, to be honest. Should we do like the Golang implementation? If you just mean error handling, then yeah, try and stick to optional. Now there's a new type in C++ as well, for those who are kind of into C++, they should know this already. std result, or sorry, std expect. I'm looking at the Rust alternative. So this is basically a copy of the Rust's C++, sorry, the Rust's std result type. So this works in the same way. So it can either be like an OK type or an error type, right? So it kind of does this very efficiently. If you don't have access to C++ 23, however slim, try and use optional. Yeah, optional is very good because then, you know, for every error that you can send back, you can just send back an optional value, right? And then log an error before. Sorry, if you send back an error, if you have an error, then you should send back a null opt instead of the actual type itself. Anyway, so now if you're talking about handling actual exceptions, because exceptions are types in C++, right? So we have actual exceptions in C++. We can leave that for another video because it's, yeah, there's too many caveats with exceptions, and it's not very efficient. That's why I kind of try not to use exceptions at all in C++. So I like this. So if the same as head value return 0, this can be used as follows. Now I'm kind of thinking that what happens if we don't have, if this goes on forever? Because this is assuming that the target type is in the list somewhere, right? Is in the list somewhere. I guess, list head could be void at some point, so it will never be a value. Or if you have a variadically templated type and want to get an index in it. I'm analyzing this because this is actually quite an important part of our algorithm. So we have the types here, and we have get index of returns get index of types. Yeah, we're gonna use this. I like this. I very much like this, right? So why not? Now let's put that in here somewhere. We're not gonna export it. We're adding all of our templating helper functions in here. So gets the index of a type in the list of types. Template types, right? I don't know why that is capital. So T parameter target should be the class or type we want to find the index for. List head, first type in the list of template args, the remaining. Now, we don't actually have to explicitly pass the list head in here. I believe this is automatically done for us in C++ 17. I'm not too sure though. But we will try to do this anyway. So return a stud size t that represents the index of target in list head, list tails. Now, a good question would be like, I still don't know what happens if target is not in the list types, because we might have to actually return a stud optional here. Just for the sake of doing things properly. Okay. Now I like this, and it kind of really, it's kind of very, very readable anyway. It makes use of the same and if const expr in C++, which are very, very, very good additions to the standard in my opinion. Now, can I export this real quick? Can I export this function? Because I'm going to try and like run it on the main thing here. So for example, I'm going to do an auto const. Let's put this at the top because I don't want to have to run all of this shit, you know? So if we do ECS, I'll use std expected. Thanks. No worries, man. ECS. What was the function called now? So it's called get type index and template list. Get type index. That's all I'm going to do. Get type index. In fact, to make it more in line with the coding standards that we have here, get type index. Yeah, so let's see. So say we had like, oh, I do actually need my types. Rect and then circle. So I'm expecting here to get like the index 1, right? I'm pretty sure it will not build. Oh, what am I doing? This certainly will not build. But we'll see. There you go. Warning declaration does not declare anything. That's quite right. That is actually quite right. Let's just comment that out for now. Yeah. And it will not compile because, ooh. Let's try that now. Error. Use of undeclared identifier target. Sorry? Use of undeclared identifier target. There you get target index. I'm a bit confused now. Is that the first error? Expected template. Expected template here. Export const expert. Size T. Get index. And what's the actual issue here? This is. Am I missing some syntax somewhere? Target list tails. Why did we have this last time? I swear we've seen this error before and it was something completely unrelated. Use of undeclared identifier target. It is identified though. It's here. It is there. So is same. Maybe is same is the one that we're missing. I am missing that header 100%. So type trades, that's the one. Ooh. Could that be the issue? Expected template. Oh, why? What if I remove the export? Is it the export keyword that's kind of messing up? Union member m value has reference type const whatever circle. Error static assertion failed due to requirement is object v. What? Like just tell me where it is, will you? It is definitely this that's failing, but target list head tail. I think we're doing something wrong here. I don't know what it is, but I don't know why this doesn't compile. Identify a target. It's undeclared. Do we have size T anywhere? Yeah, we do have the header for it, right? Out of interest. Yeah, if you don't include CSTD def or CSTD int, I can't remember which one it is. One of them will not have the size types, but that's not the issue here. Undeclared use of undeclared identifier. Why is this not compiling? Let's Google it, right? Now, in the last stream, when we had something like this, it took us about 50 minutes to figure out what it was, and it was something completely different. And I just had to like bisect the changes. Could you send me the std accept documentation? I can't. Std accept. It's not accept, it's expected. That's why you can't find it. std expected. You see? I'm not sure if I said expect or accept, but it was not accept. It was this one. But here it is, dude. Have fun. So, use of undeclared identified in C++ templates and inheritance duplicate. Yeah, last time we had this was because we were using the same template name for a function and the class itself as well. So, expected template. Thank you. No worries, man. Yeah, like what the hell is like? Why is this so simple? Yeah, it doesn't compile. getTypeIndex is a function that returns the size t const expr, and it is exported. Right? Is this how we do export? Maybe I'm missing out. Maybe I don't know like which order it's meant to be here. So C++ modules export template. Or do we have to export templates as well? That'll be interesting. I'm creating a library and I have a class template inside the C++20 module. And I want to add an instantiation in order to reduce compilation time for every project that uses my library. Are these different type implementations equivalent, or is there a better way to achieve it? So we have export template. It comes before the export. That's why. There you go. I think problem solved, right? Right? Oh, this better compile. No. I mean, it's a bit better, I guess, but union member m value has reference type const. In instantiation of class optional. Just tell me where it is, man, please. Line 80. Right, so get. What the hell? This was definitely compiling before. Member reference type std optional circle is not a pointer. Did you mean to use dot? Did I mean to use dot? What? Draw circle is equals to that. No, I didn't mean to use dot. Draw. I meant to use this. Anyway, let's just remove that because this is not necessary for now anyway. We just want to test that function. So get index type. No template name, get index type, and namespace is. Wait. What? But it should be. Get type index. Get type index. It definitely is a template. Did you simply mean get type index? What in the hell? Why are templates in C++ so damn difficult with modules? Export module mod. Export template type T. Yeah, there's nothing syntactically that I'm doing wrong here, which is kind of interesting. And as far as I know, you can just put templates in a module anyway, because obviously with traditional C++ where you have headers and source files, right? You have to put all of the template implementation stuff on the header because your compilation units have to be able to see that definition or the definitions at compile time, right? It has to be able to instantiate the template for a particular time, for a particular type at compile time, and hence why you have the implementation of templates on the header files. But that does not apply to modules. With modules, you can just put it in the module file. You shouldn't have to do anything special. And I wonder what is actually going on here. Because in theory, this should work just fine. Now, no template name get type index in namespace me. Oh yeah, I did. That is correct. I'm just being an absolute idiot here because look, it says that there's no function called getTypeIndex in the namespace ECS. Did you simply mean getTypeIndex? Yes, I do. I meant to do it without the namespace. Thank you very much, compiler. In this case, the compiler was actually helpful, but now we have another issue. What is the other issue? Draw color is a get. This is simply an optional, right? Get ID. Member reference type, color ID is not appointed. Did you mean to use? No, I meant to use an optional. Optional has the, optional objects in C++ have the operator arrow because it kind of just dereferences it. But there's an error type in the function, right? So where is it? Yeah, I saw that this is an error type. Optional. Where's my function get? Let's just see what the hell is going on. Here. No viable convert. Oh, yeah, this is a difficult one. So from here, we want to return a constant reference to a component object, right? And I think the way we did that is we found the component ID in the map, and then we found the component itself, and then we get the vector of the component, the vector of the pairs. Ah, yes, it's because the component stuff here is not a variant. That's why. Yeah, this is returning a vector of pairs, right? So we have entiy and what was it again? The variant now. So in other words, we need to find the entity in the vector. Now we're going to make this quick and dirty here just to get things working, and it's not going to be efficient, but it is what it is. We're just going to use an off-the-shelf stuff here. So algorithm find, okay, yeah. So we do have algorithm already, I believe, right? Yeah, we do. Stud find is the one. I think the actual value is whatever the entity ID is supposed to be, right? Wait, does std find actually take a lambda? Because we don't want to find it by the value itself. We want to find it by the first value of the pair, which implies that we should be able to pass in each element in the vector to a lambda and then just check on the key itself, right? So, gosh, today's stream is very, I'm sorry guys, it's going to be complicated, but yeah. Oh, I love looking for something like stud find and then I just see how my website does extremely bad on these searches. Thanks Google, it's really getting my motivation high up. I used to be, believe me, I used to be like on the first free results of certain like CMake and C++ searches back when I did blogging, because I don't really do blogging anymore. It was fun, but it wasn't really my calling. My calling is YouTube. That's why I'm here. But right now it's just doing very, very bad. My website is doing extremely bad. I wonder how many of you actually found me from my website, because it's doing bad, but it still gets a lot of views compared to my YouTube. It actually gets more than the YouTube. It's surprising, very, very surprising. Anyway, going back to this, do we have a variant of this function that takes a, yeah, there you go, unary prediction. So we have a version, this is something that's very, very useful in the standard actually. So whenever you guys are looking for looking for documentation of a function such as stud find or std find, usually, there is a version of the function that's in the simplest form where it takes the input iterator to the first element, the input iterator to the last element, And then in this case here, because it's a find algorithm, it also takes a value that's going to compare against, it's going to compare each element against the value and then return to you if you found it or not. But with these functions, there's usually an alternative where instead of a value, it takes in a lambda value, a lambda function, and it uses that lambda function to compare the value. So if you have something like a pair or a tuple, and you want to basically find an element that has a particular value at an index in that tuple or value or whatever, you want to do some calculation to it, you should probably use the version with the lambda, which is what you're looking for anyway. Hello, Anirudh. Welcome to the stream, man. I think it's probably the second time I see you here, man. Sad speaker emoji. I like that. That's how I feel right now, man. That's how I feel right now. In fact, that's how I feel working with C++ all the time. By the way, if you guys are watching this, please like the video. It does help me out massively. But anyway, so we do have that, right? So we can do an autoconst here, value, all of this just to figure out that we had this. And we can do something like auto const. What we do have is the element there, or the ID, and the component that is equals to val. Oh, return ID equals, what is it meant to be? Entity ID. This is very inefficient. This is actually like, we need to put a to-do here. This is essentially a linear search, right? So it's inefficient. Third time. Oh, third time, man. I do apologize. Yeah, I do remember your name, but I thought it was like the second time. I remember. Next time will be your fourth time, right? So I will say that. I will remember it. I'm not very good remembering names, but I'm very good at remembering my subs' names, though. In fact, like, I'm very, very bad at remembering names of people in real life. I've met people in parties and like in friend groups, and I've met them for like maybe 4 times, and I always forget their names. I keep forgetting it, and it's just crazy. I feel really bad though, because I'm like, hey, hello you, I forgot your name, and then I have to be shamed basically. But anyway, we have a very inefficient search here. And what we actually do is, if we haven't found the element, we need to do something, right? So if element is equals to the end iterator for the vector that we've just found, right? So entity components so I have entity components there. Now this should be a little bit better, right? Because here we say if it's the end of entity components, we're going to return no lopped. Is it no lopped here? Yeah. Who was asking me about the error handling? This is an example using no lopped, by the way. I think Slim was here, right? So this function, for example, returns no lopped whenever we have an error. So if we're requesting an entity ID, actually this shouldn't really be, it should just be an assertion here. We don't need to do this if statement. But yeah, whenever we have an error here, we basically return a no lopped. I mean, I'm going to put, should this be an assert? Because it should really be an assert. I've run out of Coke Zero now. So std variant component, yeah. So this is when we can do element.second, because we know for sure that it does exist in the vector, and we can return the component itself, entiy components, right? So I think this should compile, or it should at least be, oh, entity ID is not equal to that. Yeah, that's because we haven't captured it. Don't forget to capture your values, guys, if you're working with lambdas. Entity ID. Please compile. Please compile. std no lopped. No viable conversion from return value of const no lopped to function to return type stud optional circle. What? std no lopped. Why does it not work? What? Why can't I return an optional, a no lopped, instead of an optional value of a reference, essentially? No viable conversion from returned value of type const no lopped to function return type. So this is a const. What the hell? That is an interesting one. So why does it not convert? Why does it not convert a constant no lopped to whatever it should be? I'm trying to pass a vector to a function argument parameter. Wait, I'm still confused. Like, why does it not just work? Return an optional of a... This is very bad, by the way. Rust will not let us do this. Like, returning a reference to a value inside a vector or something without lifetimes. This would be like a lifetime issue in Rust, because we're returning a reference to an element in a vector somewhere. But really, the parent, the reference could go out of scope, could stay in scope while the parent is kind of deleted or something, right? So this would be a lifetime issue in Rust, and C++ just lets us do this, which is nice. But why does it not work? Candidate constructor, the implicit copy constructor not viable. No known conversion from const no lopped to const optional circle for the first argument. So I think the issue here is that we're really kind of copying this, right? I mean, we're really... Yeah, the thing with optional is that whatever you're storing inside optional in C++ has to have a copy constructor or a copy constructor, and there's an operator as well, the equals operator, right? The problem with references is that they don't really have that by default. But to change this, I'm instead just going to pass in an optional there of C, right? So we're going to copy it, basically. We're going to copy it. So this should now go away, and the issue here should also go away, but if we remove that thing. Now, we have a different issue, and we're going to figure that out. So draw the, again, no viable conversion from optional. Yeah. Now this is okay because we know what the issue is. We're just copying the data. I'm not gonna lie, in the long run, we don't want to have to copy the data itself. We want to be able to return some sort of like shared pointer or whatever, because these components can get quite big. So if you have like a mesh component, you know, it can get quite big. So no viable conversion from optional circle to optional of rect. Yeah, that's quite right. It should have been rect, right? Hello, Mostlight. How's it going, man? Dude, I know you're on my Discord. This must be like the 5th time I see you on the stream, but I keep forgetting your Discord name, so I'm gonna refer to you as Mostlight. Now, what is the dumb issue? Another dense. Jesus Christ, why can't I get this to compile? This is crazy. Is this why we didn't finish this last stream? Because it's just a rabbit hole? Look at how many errors we get. Jesus. I'm fine. How are you doing, bro? I'm doing good, man. I'm doing good. Better now that you're here. I always like seeing familiar faces on stream. It's good to it's good to see that people come back to the stream. So could not match variant against pair. Yes, but where? Where? It's going to be on the get function for sure. It just doesn't have the line number in there. So it's going to be here in the get result. So could not match element second to variant. Yeah, that's right. Element second dot second, boy. There you go. When working with pairs and iterators, second. That's better now. That's a little bit better. Until you start posting, I won't even leave you, mate. I don't leave people who taught me stuff. Yeah, that's good to hear, man. It's good to hear. I love teaching people stuff. No matching function call to object type. So this is going to be a pair, right? Because it's going to find the element, and this is basically a pair. No member named. Second invariant circle. What? Let me see something. So we have that vector of pairs, right? And then we find it. We find whichever element it is, and we put that in entity component. Ah, yeah, it is because it's called entity component. If element is equals to this, so element at this point is basically an iterator is an iter to a pair of ID to vector or to component actually, right? So by doing this, element.second, just curious, why are you making the ECS? Did you have a particular game simulation in mind that you wanted to, or for just for practice? Yeah, it was basically for practice. Hello, Codekill, by the way, welcome to the stream. It was basically for practice, but now I have this idea in mind that I want to make a rendering engine, right? And the most basic thing with a rendering engine is to have some sort of ECS working. And I thought, why not? Let's just make it. I've never actually worked with ECSs before, and I kind of have to use it now for work because we do have ECSs everywhere. And I thought to myself, yeah, let me just learn how this works, and that just helps me understand things, which is always a good thing to do, actually. So when you don't understand something well enough, it's always a good idea to kind of go deep into it and implement it yourself, because you're going to learn a lot of things. Like right now, I can see how freaking difficult it is to do anything that's kind of generic enough. So you can just create like an ECS registry with some classes, and it will use them as component. All of this work that we're doing right now is just to make things as generic as possible, and it is crazy. It is crazy how difficult it is. Well, you know, that's it really. There's not much you can do about it. You're just gonna have to sit through the errors and fix them. Like we've talked a little bit about the caching stuff at the beginning of the stream, but we haven't actually gotten to work on it yet, just because we're fixing things from the last stream. So yeah, it's a little bit of a shame, but you know, I'm gonna have to change the title to something like something like fixing errors non-stop in C++. So element.second and then .second. This should work. This should work because this element.second wait, what? So this is an iterator to pair. What is this? But then if I leave that in there, it says that you can't convert element.second to the variant. Right, I'm gonna just have a look at the last error somewhere. Or the first error, I guess. Instantiation of class. Optional. I'm just looking for a line in here. Optional line 30. There you go. So this is it. This is in our code where it happens. This is again in our code. Here, okay. That's a little bit better. So entity ID, so the value itself. What? If the ID is equals to entity ID. So error, invalid operand to binary expression. Huh? I'm so confused now. I thought the issue was converting between variant and pair. Return iterator equals value. ID. The entity component is going to be the vector, right? For sure. Let me just, I'm going to automatically put, this is the thing with working with auto. Sometimes it is just good putting the actual types to make sure that it's what you expect, right? So we have a vector of pair here. We have an entity ID there. And we also have a component, I believe, right? Right? Component of T's, right? So component of C's. I'm going to compile it one by one and find this error because the compiler is not being very helpful to us. Are we also using the wrong thing? Is it type? Is it find if? I am not wondering now. I just realized. There you go. I mean, we got past one error. Main. Now we're still messed up here. It is find if, right? That's the right function. I'm not just dreaming. So find if searches for an element for which predicate P returns true. Find if not searches for that. Okay, good. But I don't see why the static assertion failed due to requirement object. I mean, this is definitely the issue, isn't it? I wish I would actually have like a line reference to where it's actually failing to compile instead of just giving me some bullshit like stack errors here. I mean, yeah, it fails to compile this line, but draw color. Oh yeah. It fails to compile that line, but why? Oh my god. Okay. Look at this, like this is another rant in C++. So when you're working with something like this and you see something, let's see what the actual error message is. Error, static assertion failed due to requirement. Is object, const anonymous namespace color reference. Static assertion is not an object and is not an array. So note, an instantiation of template class, optional const color reference requested here. Dune, this line. Like, I have no idea what this means. Like, who came? I don't understand why the compiler is so bad at giving this error diagnostics. For those who are wondering, the issue here is that getColor will return me an actual color object, and it doesn't get converted to a const reference. That's the issue here, right? Optional doesn't allow you to do that because const reference doesn't have copy constructors. I mean, I assume that's the case, right? But when we remove those, it kind of just works. So yeah, it's interesting. And things worked. Finally, like only now, we're able to actually test what I was meant to test, which is testing this getTypeID function here. So basically this function gets where in the list of types the circle is. So I expect it to return 1 here, right? Which kind of works, right? And then if we did something a little bit better, so what do we have here? Position, rect, circle, color, and if we also have a struct triangle, and if I had a triangle here, let's just put the size of A, B, and C, right? So we have the sizes of the free stuff, the free oh my god, the free sides of the triangle. But you know, we're not actually going to use this. This is just so we can have another type there, and I can test this function with a few more types, basically. So we have triangle there, and we also have the position, right? That's what we had here. So if I now went to find triangle, I expect it to return 1, 2, 0, 1, 2, right? So I expect it to return 2. And I'm just like testing this to make sure the fundamental function that we need for our caching works. Because we fundamentally need something that will return us the index of a type in our component IDs, right? Which is a variadic template, or I forgot what it's called when you have like many templates in C++ with the ellipses. And it kind of works, right? Now, what happens when this doesn't have a type? That's what I'm interested in finding. So if we had another struct up here that was a different component, right? And let's call it the render component or something like that. Now, if we didn't register this in the registry, like what actually happens? So if I did something like that, because this is interesting, someone could potentially call this API with something that's not going to work, right? I expect it to fail at compile time. There you go, it does, which is good. This is what we want to happen, right? We want this to fail if render is not in this list here. We want this to happen. So yeah, amazing. Now going back to our plan, it's good to take a step back and actually breathe a little bit after we've gone through all of those C++ error fixing and figure out what we should be doing, right? So the plan here is to have a function that will get the bit mask of whatever type this is in our list of C's, right? So that's what we're going to do. So we have that function again that's going to generate the ID for a map. So where is it? It's here. No, it's not. It's not there. It's not there. This fails. We're fine with that. Let's just remove that line of code. I'm going to build it again. Just remove that squiggly line. Oh, what? Undeclared identifier render. That's something I didn't test actually. What happens if it's the first element? It should return 0, right? So 0 should be returned in this case. So rect in this list here is at position 0. And we have position 0. Beautiful. Now this is going to be the foundation for our function for generating IDs to the new map, right? Because we want to get, as I explained, that map something like this, a bit mask, to a vector of entities. And this is how we're going to do it. So we need to be able to turn a list of entity lookup or component lookup queries into an ID. So we can find it in the map which entities are stored in the vector for that bit mask, which means all of those entities will have both or all of the components mentioned in the template arguments, right? This is the bread and butter of things. So this ID function is extremely important to us. Get type index, we're going to need that. We don't need to export it anymore. We've tested it well enough. So this can just stay in here and get optimized away by the compiler. What we do need is to have bitmask function implemented here. So the subcomponents, we're fine with that, right? So what do we want to do? We want to go through each subcomponent in the subcomponents and find which positions they're in and create like an array of that. So let's suppose we have an array here of size t, right? And this will be the size of subcomponents, right? That's what we're gonna have. So there isn't a smart way of doing this in C++. I know for sure. Well, I've done this before. Where is it? Array, type arrays, array size. There is a way to expand an array into like a function that calculates something for the components. Let me just figure out what that is. By the way, if any of you guys do know C++ very well and you know what I'm looking for, please feel free to tell me. Out of interest, there's a few people watching us. Like, how many of you actually do C++ on a daily basis? I'm wondering now, because I'm kind of rambling on a lot about very kind of not high level, but very complex things in the C++ language, and I'm not entirely sure that this is getting absorbed by many people here. So. I'm just wondering if I'm talking too much about things that are just not relevant. C++ arrays, expand parameter pack. Parameter pack, that's the one. How do I expand the compile time std array into a parameter pack? Size of array, no, simple way to convert parameter pack to array at compile time. To array, return stood forward arguments. That's not what I want though. By the way, for those who have joined us and haven't yet done it, please like the video. It does help me out quite a lot, guys, and I appreciate that. Thank you. Yeah, what I'm looking for is, like, in C++ we have parameter packs, which are, you can think of it as variadic template arguments. There is a way to turn this list of types into an array, which an array of values which are calculated by taking each of the types in the parameter pack and applying that function to them. That is what I'm looking, and it's basically essentially like a map function for parameter packs, right? That's what we're looking for. I just can't remember the syntax for it. So C++ map parameter pack. How can I map a parameter pack? Here, this is the one, right? So args.s. Okay. So I guess we can do something like this. So can I do const expr here? Can I also do const expr here? And that is going to be equals to what? What did we have? Yeah, this is where that function that we've just worked on comes in. So get type index is the one. So get type index of subcomponents, I guess. Ooh, this is interesting now. Oh yeah, no, I can't do this actually. Just realized, because I don't really have the type, the head type in here. This is going to be a little bit more difficult than I thought. So this is definitely going to be more difficult than I thought. So let's think of a different approach here. So we have like all of the possible subcomponents, right? It would be nice if we can iterate over each one of these values in the parameter pack, and like shift a bit in the bit mask, right? So for example, we start with a size t, which is the result, which is a 0 there, and then for every type in subcomponents, we kind of do something like dude, I can just hear massive random noises outside for some reason. Like someone's above me, even though I'm on a top floor apartment. Spooky as hell. What? There you go. So for every subcomponent, we do like a result or whatever get type index for my type in C's, right? And C's, by the way, is the actual types that are registered in my registry. That's what it is. This is what I want to do, right? Something like this. So is it possible in C++? Definitely. Do I have to do recursion with parameter packs? I think so. Periodic templates of specific type. For loop. It would be nice if there was a for loop though. Oh no, this is Swift. I want C++, brother. C++. Is there a way to iterate over the types without having to do what is it called? Oh my god, the word just went out of my mouth. Freaking the opposite of a for loop. What is it? Recursion. That's the one. Without having to recurse over things. I think it is. Iterate through types in parameter pack. I tried to do this with a parameter pack. Okay. Yeah, you can turn any for loop into recursion, by the way. It's not difficult. I just find it extremely unreadable when we do that. So yeah, I don't like doing that, but it might just be what we have to do here, unfortunately. I've heard of a method, but I cannot remember. YOLO. Hello, YOLO. I think this is definitely the second time I'm seeing you on the stream. Welcome. I think, if I'm not mistaken, you actually did know quite a bit of C++ last time. So I'm happy that you're here, man. You might be able to help me. Yeah, I mean, I might just have to iterate over these things. So not iterate, just recurse over these things. Yeah, so basically the result is going to be something like ORed with the bit mask. Let me think now. Yeah, we can just do a recursion function in here. Oh, a bit annoying though. So get type index. We already have get type index. So this will get the index of target in a list of types, right? So we can just use that, right? Can we just use that? Yeah, we can just use that, right? We can just do something like get type index. Oh no, yeah, no, I do need to define a function that will turn this subcomponent into a into a list of head and tails, right? So yeah, let's do that. So template type name head tail const x per bit mask helper. We want to return a size t here, definitely. So size t result is equals to 0. Now, if const expr, right? What do we do? There's a void type, right? We can do an is same. So is same. Is there a type? There is something to call is same with a void type? Oh gosh. C++ is same void. Want to make sure that we're like, if we reach the tail, we don't recurse anymore. So is void. So it's in type traits again. std is void is a unary type trait. Checks whether t is a void type. Provides the member constant value that is equals to true. So if the head is void, right? Yeah, we can do that. So is void, and oh no, this is the wrong function. So if we do an if const expr here, and we have is void head there, and this would return true, right? Is it value? How do I actually use this void? That's an interesting one. std is void v equals true. So this evaluates to true no matter what. Is volatile void decal type true false. Okay. So this is kind of what we want, right? So if const expr all of this. In other words, if we don't have a type here, we return 0. Else, we simply return result and whatever the bit mask helper is, bit mask helper of tail. Wait, let me think. So result is 0, and then return. We OR it. We don't need that for sure. But what we do need is the get type index. Otherwise, it's not going to work. ORed with that. Yeah, that's the one. Gosh, this is like, we're getting down to bit operations, which I hate working with bit operations. Just, it's very confusing sometimes. But yeah, we have something that should compile, hopefully. So let's go back to the bit mask and actually ask this ourselves. So now we do, this becomes a very simple function now, right? So we have get type index. Oh no, we've made a mistake. We've made a mistake. Because ideally I want to set a bit inside my uint64 based on wherever the head type is in tail. Wait, no, this is, what am I doing, guys? What am I doing? See, like, it's so difficult. I've already forgot what I'm doing. So we want to be able to get a step back and see. We want to be able to get a bit mask depending on where the type is, right? So for example, in this case here where we have a registry of circle and square components, if we do a bit mask of the circle, it will return to me 0, 1. That's what we want. If it's a square, it's going to be 1, 0 because that's the second value, right? So we just OR it. That's what we want to do. Why don't you use bit set? Because bit set doesn't actually bring us any value here. So you can index them like arrays. Yeah, I can index them like arrays, but this is not the problem that I have here. The problem I have is basically finding indexes of a type in a parameter pack. This is the main problem here. And based on that index, I'm then gonna create a key here, so it's a uint64 with a bit value set to wherever that index is, right? This is the problem here. But yeah, bit set can be useful. And in this case, it doesn't really bring us any, like we can just do this with integers as well. It's not a problem. So bitmask helper, what should this actually do? Yeah, so we have bitmask helper, we have index type. This is what we want. And I think this might just work. I think this might just work, right? So we have get index type of headers in C's. Now this function has to be in the class, and I'll tell you why it has to be in the class, because it needs to have access to the parameter pack of my registry, right? And it probably does have to be a private function as well, I guess. So down here. And please don't give me a bullshit about the type not being defined. So this is kind of what we want here. Wait, where is the closing bracket for this? Am I going crazy? It's here. All right. My bad. My bad, bro. Yeah, it should be something like this, right? Yeah, because this has to be something like that now. We have head into C's. I think this might just work. I'm going to compile it just for the sake of it and hope that it works. And if it doesn't, we're going to go through the errors. And it didn't. There you go. So error no return, statement in const expert function. Yeah. Return bitmask helper of subcomponents, right? I mean, ideally, we can just do this in there too. Like, yeah, we can just put all of this into this, and then just do it here. To be honest, type name tail. Let me just think about this though, because if head is just one, right? Wait, if void is true, we don't do anything. Return 0. Yeah, I think this should just work. This should just work. I don't see why it shouldn't just work. Expected an unqualified ID. No, it fucking doesn't. Oh, dude, I need to stop swearing. I'm gonna get my YouTube ban soon. Expected unqualified ID. Like, why? What is unexpected here? Am I using is void properly? Is void equals true. Is void v. Okay, yeah, that's the one. Yeah, the underscore v values are just kind of like short for is void head and then colon value. I think that's usually what the standard does. Right, this is more like it. So error, the declaration of get type index must be imported from module ECS before it is required. Yeah, that's correct, yeah. That's because we unexported it because we don't really need it anymore. That was just a test that we were doing before. And you know, it seems to work. But the thing is, what if I do something like this, right? So auto const type ID, and I do, now let's move back a little bit after we create the registry because it has to be here. So this is where I can do something like my registry the bit, what was it called? Bit mask, right? Of, let's say we want circle. So I expect this to be, you know, to be 1. That's what I expect here. Now, because we're using this function, it might not actually compile. There you go. So bit mask, what is it? Error unused identifier bit mask helper. Yeah, that's because it's just bit mask. It's a bit annoying that C++ doesn't actually look at it until you actually use the function, though. It should still look at it, right? I feel Rust does it. Why can't C++ do it? Right, no matching member function to call bit mask. Now this is interesting. Error, no matching member function for call to bit mask. Like, why? It's right here. It is right here. No, candidate template ignored. Couldn't infer template argument head. Couldn't infer template argument head. But bro, this is where you do it. You should just expand, right? Head is now going to be the first value of tail. So if this is void, we return 0. Do you guys like get any of this out of interest? Like, does anyone actually follow? Because if I'm having a hard time following this, I expect that you guys are also having an even harder time. But hopefully together we are learning something, right? That's the important thing. Yeah, so why can it not infer argument head here? I learned how to template like a few days ago, so I can't really help. Yeah, dude, I mean, it's good. I mean, I learned how to template 10 years ago, man, and I'm still struggling here, so don't worry about it. You will always struggle. Always struggle, man. Yeah, bit mask of tail. All easy going, no problem. Hello, Al. It's good to see you, man. Al, do you do C++, man? Have you ever done any C++, dude? Because, like, if not, just stay away from it, man. Template metaprogramming is definitely difficult. So bit mask of tail, like, I don't understand why this can't infer the type of head. Like, theoretically, this should just be able to, like, expand. Could not infer template argument head. Like, why? Like, you have all the information there. The compiler knows all the information that we need. I mean, maybe you have to specify head exists and tail size is more than 1. Yeah, I'm thinking that as well, but like, in theory, when you do ... in C++ like this, it expands things, right? So it's the same as me calling this with like concrete classes like circle, rect, you know, triangle, or whatever. It's the same. This is what it does. So head is circle, and then the tail should be rect and triangle. I'm gonna Google it and see why. Like, you are. I think you are right in the end, though. I think it just, you know, literally we have to specify something. Only if I have an urge to feel depressed. Yeah. I feel you, bro. I feel you, bro. I wanted to develop a game engine when I started to learn C++. It was no fun. Well, you might be in luck, Al, because we're going to start developing a game engine soon. The idea for this is to turn it into a rendering engine. But before that, I would like to have a basic ECS working, which means we're going to have to do a few more streams on this. Maybe, you know, maybe 3 or 4 streams, maybe 5, who knows. But at this rate, it's probably going to be like 10 streams, which, you know, it's going to be fun. But, you know, when we have something working, and we can get things like mesh components, we can get all the data we need into components, then we can do a very, very easy rendering engine. But what if there was no classes? It wouldn't call bitmask with no classes, like bitmask 0. It would have no head, etc. You are correct, but this is where constexpr if come in. Because if it is a void here, you see, if the head is a void, so in other words, if there's no type in there, is what you mean, then it returns 0. It should not compile this at all. You know, this is the key here. This is what I'm thinking, you see. So yeah, just to summarize, this is where if const expert comes in. It makes things a lot nicer. Error, no matching member function to call bitmask. No, instantiation, whatever. Wait, where does it say is ignored again? Couldn't, there you go. Couldn't infer template argument head. C++, couldn't infer template argument. There you go. It's the top search. So, you know, a lot of people have this issue. Candidate template ignored because the template argument could not be inferred. Let's see what they have here. The argument k in const type name akx is not deductible. Basically, everything on the left is a dot is not deductible. If colon separates nested name, k cannot be deduced, hence is non-deduced context. So template type name k, a of k. Yeah, like what? An instantiation of function template specialization. Couldn't candidate template ignored. Couldn't infer template argument head. But why does it need to do that? This is giving me a headache now. This is literally giving me a headache. Like, this is the same logic as we have up here. Like, we have a function that does exactly the same. So this one here, for example, it says if const expert, if this target is the same as the head, then we return 0, right? Because it found the position. Otherwise, it's 1 plus whatever it is. So list head is inferred from this here. I'm not sure if you guys can see it. So list head becomes part of the tails. So the first element of list tails is going to be inferred as the head, and the remaining stuff is going to be the tail still. So add variadic template to your Google search. Good point. Yeah, I didn't do that. It's actually called parameter pack, multiple variadic template not bounded to function arguments. Couldn't infer template type. Let's see what they have here though. So type is what we couldn't infer. In other words, that thing here, type. Oh gosh. Oh yeah, this is easy. That's because they have a parameter pack in the middle of things. Parameter packs are only allowed to be at the end. You know, because the compiler, you know, can't possibly figure out how many types should be inside args, and you know which one is going to be type, and then which one's going to be types in the end. This doesn't exist, right? There you go. Put the juiced arguments last. There you go. So this is not the same in this case. Let's search for parameter pack. Function template parameter pack, not at the end of the parameter list. Yeah, we can't have this as we established. Class types. Yeah, this is not a problem though. Yeah, we have the type at the very end. What does GPT help us in this case? Let's see. I am wondering. When you don't know, GPT it. And sometimes we'll just absolutely mess up, but we will see. C's is up here. Okay. Let's see what GPT comes up with. Why does the following code give me the compilation. There you go. Couldn't infer this shit. Argument head. Copy. And let's see. Is it maybe because you have C's and tails as template parameter packs? So C's comes from the class, and it shouldn't be a problem here. It does have access to those. If you look at C's here, it should be inside the actual class definition. So the registry actually only depends on C's, because C's are the names of the structures that I'm using as components, right? So this is what the user sees. The user will use as components. I don't want to use C's for vision. So C's are those types. Now the function that we're making also has tail, which is a different parameter pack. And it's a good point. I'm not sure, because we essentially have two parameter packs, but they are from different contexts. So it should be able, the compiler knows enough to work this out. What is this answer? Like, how long is this? The error couldn't infer template argument head occurs because the compiler is unable to deduce the type for the template parameter head when you call the bitmask function. Template argument deduction is a process where the compiler, we know about this, I don't want to... No arguments for deduction. Your bitmask function does not take any parameters. Therefore, the compiler has no basis to infer what type should be substituted for head and tail. Okay. Yeah, that kind of makes sense. That's making sense. So how do I fix this? Additionally, ensure that the base case for recursion is handled. You might need specialization or overload for the base. Ah! Yeah. No. Yeah? So if tail is... If head is like the last element of tail now, tail will essentially be void. Maybe is that what Yola was saying before? Because that kind of makes sense. I read it differently. So in other words, when tail is void, does this fail? Because if it does, yeah, let's see. So basically, we're adding a base case for when tail is... Oh, bitmask. There you go. It doesn't work, does it? No function template matches the template bitmask. No, I get a different error. So why doesn't this work? Why does it not let me define a base case for it? No function template matches function template specialization. Is it because it has to be after? I think it just means it has to be after, right? Let's see this. No, it's still the same error, right? A parameter pack is allowed to have 0 elements. So you have a base case for a template with... So you have a base case. Yeah. I think you need a base case for 0 elements. Thank you. I am adding that right now, but no luck though. It still brings me some issues. What is this issue though? No function template matches function template specialization bitmask. Candidate ignored. Couldn't infer the type head. Yeah, so this is the base case, so why does it not work? Come on. I mean, we can, in the same function we can do if const expr, right? Std is void, I guess. V tail. Does this work? I don't know. I'm not sure if I can use a parameter pack in tail here. Too few templates arguments for variable is void. Or too few. No, this is too many, I think. Now, is there a type trait that I can actually use to see if Wait, can I do a size of actually? Ease of undeclared, size of. Did you mean size of? Yeah, I did. Now I know this is not right because I still have to do this. Oh yeah, no member. There you go. So we still have the same issue. I am getting uneasy now. No matching member function call to bitmask. Candidate template ignored. Couldn't infer template argument head. Context precise t bitmask. Dude, like, why is this so difficult? No matching member function call to bitmask. Because like I know this is not correct because we still have like to return the index for the head. But I was hoping that if I put a base case here, a context per base case when the size of tail is 0, this would disappear because then it will tell me that the issue is when tail is equals to 0, right? Which is a bit of a shame. Bit of a shame indeed. I keep staring at it. I keep trying to think of what it could be. But I have no idea. Bitmask. So we've tried adding a specialization for this. We've tried everything, right? And nothing is really working. Which is interesting because we have the same logic. Like that's the thing, we have the same logic elsewhere. If we look at this function up here where we have, there you go, get index type, it also has the same thing. Maybe I should put it in an else statement. Ah, that's right. Maybe it should be in an else statement. I'm not sure if the compiler is going to like this better. Because maybe this is the only way to force the compiler into only running the return thing here. If the head is void. But no, it doesn't work. Anyway, it doesn't really work. Couldn't infer type head. And now we need it. Oh yeah, of course. So this is very ugly, but is this gonna work? Because if it does work, I'm actually gonna be very happy and it fucking works. Oh gosh, that was a wild ride, wasn't it? All of this to write some if context per stuff. So yeah, there's actually two base cases here. That's the problem with the logic. So for those who were like wondering, and if you're still watching this, I wouldn't be mad if you guys just tuned off. If you just tuned out for this whole thing, So we have a base case where the void is equals, where the head is equals to void, right? So when we have no elements here, this is the ultimate base case, right? So if we come into this function and head is suddenly void, then we don't call it. Now we have another base case, which is when head is something, but tail is 0, right? So when tail is 0, we don't want to have this part of the logic here because it's going to force the compiler to consider bit mask of a tail that doesn't exist. But this is the key here. So we have to do something like this. It just has to be done, I guess. In fact, this is even better because we don't actually need this stuff at all, right? It was a tautology. It was a tautology, and you guys should know what tautology is if you've done computer science, because it's the same logic inside the same logic, right? There you go. Easy peasy. All of this, 10 seconds to write this, but yeah. Anyway, so now can we actually get an ID for that particular function? So let's see. So I'm hoping that this bit mask is going to return 1, right? And if I do rect, it's going to be 2. Position is going to be 4. You get the gist. You get the gist. That's 1. Let's do all of them just to make sure that we actually have the correct stuff. Al, I bet you're like, because you joined a little bit late, Al, I think you're like, what the hell is he doing? Why is he doing all of this? The reason is so I can make caching a little bit more easy. Because I'm going to change the fundamental storage for my entities. Instead of being something like, a component ID to a list or a vector of entities and their component data, I'm going to change it to a list, to a map of IDs, where the ID represents which components the entities on that list have. So it may be that we store. It isn't. It may be. It will be the case where we have an ID that contains all of the entities and all of the components. Sorry, and all of the entities stored in that vector will have all of the components. This is what we're doing here. We're making lookup a lot faster in the long run by doing something like that. And this is just the start of it, which is unfortunate, really, because I was hoping to do a lot more today, but I'm gonna have to. We're going to have to be content with this, I guess. This is also the sort of thing that if I was on my own, I'll be able to do it a lot quicker, but streaming is streaming, isn't it? Oh, we had circle already. Where is it? Color. 1, 2, 3, 4. Now, as we said, we expect powers of 2, right? Because each of those is going to have an ID itself. I wasn't able to follow the whole ECS streams. Yeah, no worries, man. I mean, you're here for the C++, right? So this works quite well. Now, what if I do a composite IP? So auto const my ID 3, my composite ID. If I do color and rect, this should be a value of 3. That is what I expect here. Happy you got it working though. Yeah, I'm happy as well, dude. I'm going to call off the stream in a bit, but I'm just going to run some tests now to make sure we pass. So this should be 3. 10. Ooh, that's not good. Why? That is not good at all. Let's run that again and see what the hell is happening here. Because it should be whatever, like 1 odd with 2, right? So it's 10. Rect is 2 and color is 8. Rect is 2 and color is 8. Oh yeah, of course. I thought I was doing circle for some reason. Dude, I got scared off there. It's 10. Yeah, thank you, Al. You're always here to correct my mistakes, my man. So composition seems to work. Let's do another one. So if we do 1 plus 2 plus 4, that is 7, right? Yeah, so we do those 3 and see what happens. And all of this, by the way, is just a way of generating the IDs for different combinations of components. That's what you're seeing here. This is just me generating an ID, so I can then like actually use it on the map that will be storing these things. This is just the first step, right? So right, let's do circle, rectangle. Let's actually change the order a little bit, right? So position and rectangle. So I expect to get 7 out of these, and we'll see. Seven. Yeah, there you go. Beautiful. So we do have a way to generate those IDs now. I do apologize for anyone who's watching this in the future and then just spend like 2 hours here figuring out why I took this long to create something like this. And the reason is, well, because of compile time issues, compile time template stuff in C++. The errors aren't quite nice, as you can probably tell. And, you know, at the end of the day, it just takes this long for you to be able to do something as robust as this. Oh yeah, we also fixed a bunch of compilation issues that we had from the previous stream. That took a while, didn't it? That took like 20-30 minutes, I think. But we are in a position that we can actually get entities for the issue is CPP. Yeah, the issue is CPP, yeah. But anyway, thank you all very much for joining, and you know, it was good seeing some of you again, especially you, Al. I always love seeing you here, dude. And also Kodakrill, you helped me out quite a lot today. If you're still here, you know, thank you very much. As well as YOLO and Muslight. But anyway, I will leave here because I actually have to travel to London in the morning tomorrow, so I need to get some good sleep, and it's nearly 11 already. So I'm going to call it a day, guys, but thank you very much for joining today's stream, and I will catch you hopefully on the weekend when I'm back. I'll be back on Friday, so I don't assume I'll be doing a stream then because it's going to be too late for me. But yeah, I'll see you guys next time. Again, thank you all very much, and bye-bye. That's me.